Welcome to the Geometry Final Review for Standard 8. Watch in case we need a second video for this, but I think we'll be able to finish it in one. In this one went along with that really long test that all of you loved on finding the area of a regular polygon. But I'm going to cover just some of the ideas really quick. Okay, finding angles, central, interior, exterior, finding sides, both their length and the number of, finding the area, and dealing with kind of polygons and regular polygons. Okay, first thing I want to do is kind of take a quick look at types of polygons. Okay, a polygon that isn't regular basically means it has, like this one right here has 1, 2, 3, 4, 6 sides. So it is a hexagon or a sixagon. This one has 5 sides and it is a pentagon, but it's not a regular one. Neither of these are. You can tell that some of the sides are longer, some of them are shorter. The angles don't look like they're the same. Like this one looks like it may be 90, a little more than 90. And so remember that when you're dealing with polygons that aren't regular, about the only thing that we did with those is find the sum of their interior angles, which is useful when we're trying to figure out some things about what's going on with the angles, like finding an angle if we know all the other ones. Now remember that the triangle is a special case. It's the only one where if all the angles are the same, all the sides will be the same also. That does not always happen in regular polygons so you have to check for both. Okay, here's what a regular polygon might look like. I've got a couple of them here. You can look and the angles look like they're pretty much all the same, and the sides are pretty much all the same length. And we'll use these for one of our examples here, some stuff we're going to do. Okay, so let's go ahead and look back at this shape. Let's see how many sides it has. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a nine-gon, which I believe is called a nonagon. And I want to show you how this one is regular. I want to show you how to find certain sets of angles within it. Okay, the first set of angles that we're going to find is the central angle. Now the central angles can be found by dividing the shape into a bunch of congruent triangles, and if it's regular and you do this, they will be congruent. And I have a couple of other really cool things happening too. For example, if you checked, you would find out that they are isosceles, which means that these two angles down here on each of them is going to be the same. So the opposite angles. We talked about that in the triangle unit. So how do I find the central angle of these triangles? Well, I take the number of sides, and I do 360 divided by the number of sides. And here I do 360 divided by the number of sides. That's not what I wanted. And it is, see there, put a little light on it, 40. Okay, so 40 degrees. Now, you're better off thinking than you are just memorizing this, because if you look and think about what you know about what we just talked about, if this is 40 and these triangles are all congruent, and you know a little bit about triangles, I'm just going to draw one out here to the side as a kind of an example. So just that one right there. The interior angle is, or the central angle is 40. We know it's isosceles, so we know it's got two angles here that are the same. Let's use what we know about triangles. Okay, we take 180, we subtract the 40 that's already used, we get 140, then we divide it two ways among the remaining two angles, and those angles must be 70 degrees. Now, if this angle is 70 and this angle is 70, and all these are congruent, so this one is 70. We now know what the interior angles of this regular polygon equal? Okay, they will equal, I'm going to use red here and show that. This is an interior angle right here. Goes all the way. I'll do one over here so you can kind of see a little better. Goes all the way from one side of the polygon to the next adjacent side, and it's going to be these put together. So we know that it's going to be 140. So if you had a question that said, what is the interior angle of a regular 9-gon, I think that was one of our earlier tests, this is one of the ways that you could find out that measurement. Okay. Okay. Now, we also mentioned that we want to find exterior angles. You can find an exterior angle, kind of think of it this way. If I took one of my sides, like this one, and extended it, kept it going straight, and extended it, the angle that's formed right here is the exterior angle. And the way that I find it is I take the interior angle, well, giving you too much here for a moment. The interior angle on this one, for example, is 140. So the way I find the exterior angle, since this is basically a straight line, they're supplementary, and so I do 180 minus 40, and I'm going to find out that that exterior angle is going to be 40 degrees. It is not a coincidence that that angle and that angle are the same. Your central angle on this regular 9-gon and your exterior angle will always be the same. If you have a 5-gon, a 6-gon, and they're regular, you can use the same method. So it is also found by taking 360 and dividing it by the number of sides. Now, let's get into some of the problems here. Okay, let's go ahead and run into the well, let's talk a little bit more about this. Okay, if I want to find the area of one of these shapes, like this regular pentagon here, I'm going to do a couple of steps. The first step I'm going to do is I need to find some measurements and angles. We usually do that by breaking them into triangles. So I'm going to break this into 5 congruent triangles, just like we did before. I'm going to find the central angle by doing 360 divided by 5, and I'm going to get 72 degrees. So I know that all of these angles right there are 72 degrees. I'm going to find the other two angles really quick by doing 180 minus 72 and then dividing by 2. Gives me 108, which by the way tells me that one of these angles right here is 108. Divide that by 2 and I'll get 54. So I know that each of these angles is 54 degrees. Okay, now if I can find the area of one of these triangles, I can find the area of this shape. And I'm going to have to use trigonometry, so you'll probably need to look in video 2 as we continue this example. Okay? And good luck.